Good evening, stargazers, dreamers, and cosmic explorers. I'm Paul Cox, and I'm thrilled to welcome you to tonight's extraordinary event. It is SLU's live star party celebrating the magical Perseid meteor shower. Now, whether you're joining us from the comfort of your home or backyard, we are delighted to be your guide to one of the most, what I think is the most dazzling celestial spectacles of the year, really. Now, tonight, we gather as a community of curious minds and passionate star watchers, united by our shared sense of wonder, and we're going to share some of that with you as well. The Perseids connect us to the rhythms of the cosmos, don't they? Inviting us to witness the age-old dance of fire, dust, and even ice that plays out above our heads. So settle in and prepare for an hour of awe and discovery. Now, before we dive into the magic, allow me to introduce SLU if you're new around these parts. A global network of huge robotic telescopes and an enthusiastic team dedicated to making the universe accessible to everyone. Now, through SLU's platform, we bring live views of the night sky to your fingertips, share expert insights. We foster a worldwide community of educators, students, and enthusiasts who love to look up and study space and back down from satellites to study Earth science with our interactive quest learning activities. We might have time to talk about those a bit later. But now let's turn our gaze to the Perseid meteor shower. Keep your eyes on that live feed because we have already been seeing some absolutely wonderful meteors streaming across that live feed, which is pretty cool. Anyway, each August, Earth's orbit carries us through the trail of cosmic debris left by an object called Comet Swift-Tuttle. And as those tiny fragments, some no larger than a grain of sand, plunge into our atmosphere at incredible speeds, they ignite in a brilliant cascade of shooting stars. Now, the Perseids are renowned not just for their frequency, but hopefully, as we'll see in the live feeds, for the beauty and brightness of their meteors. It's like the universe is kind of throwing its own celestial fireworks display tonight, and we're all gathered around the fire to watch it together. Now, the 87% waning gibbous moon is going to mean that we won't see as many as normal because they'll be drowned out by the moonlight. But this particular feed is well away from the moon, so we should see some more good ones in here. But the Perseids are really one of the most popular meteor showers because they occur during warm summer nights, which is ideal for watching from your own backyard. And we've got some tips at the end of the show about the best ways of doing that. Now, tonight's Star Party promises to be a fun experience. If you're not having fun, then I don't know what you need. But we're going to be streaming live views from our feed partners around the globe. This particular one is from the UK Meteor Network, Observation Network. And I believe this one comes from Oxford. So we're going to keep on this because it's a really, really good view. Now, our expert guests are going to help us explore the science behind meteor showers, the story of Comet Swift-Tuttle, how meteor showers and comets have been entwined in culture over millennia. And if you're a SLU member, we'll answer your questions if you post them in the Zoom webinar. Now, keep your eyes on the live feeds. I didn't do this earlier when the rest of the team were looking, because if there's one rule to meteor watching, it's that as soon as the epic one whizzes across the sky, that's going to happen every time you look away. So keep your eyes peeled. Now then, before we welcome our first expert guest, let me tell you a little bit more about the Perseid meteor shower. It's named after the constellation Perseus, and we'll find out why that is a little bit later. But their true origin lies far, far deeper. It's a journey that began thousands of years ago with the passage of Comet Swift-Tuttle through our solar system. Now, each year as Earth returns to the region of space where Swift-Tuttle passes, the leftover cometary dust and debris collide with our atmosphere, burning up in those spectacular flashes of light. But you know, the Perseids are more than just a scientific phenomenon. As we'll discover, with another of our special guests tonight. They're woven into the tapestry of folklore and legend. Ancient cultures saw meteor showers as omens, celestial gifts, or messages from the gods. Don't miss that segment with Milton a little bit later. But in modern times, we see them kind of as a reminder of our place in the universe, a fleeting moment where where the infinite becomes a little bit closer. It feels a little bit closer. Anyway, now let's get on with the show and welcome our first expert guest, slew educator, and many students will know him because you enjoyed his space science classes earlier this year. It's Keith Wozaleski. Hello, Keith. Welcome to
Hello,
the
Paul.
Star
Thank you for
Party.
having me for this exciting event.
I know it's going to be a good one. It's going to be a good one. Now, before we talk about this specific meteor shower, let's answer a question we've already seen from a few students at SLU this week. What is the difference between a meteoroid, a meteor, and a meteorite, Keith?
Okay, well, the meteor, well, I think we'll start there because that's what we're
Yeah.
going to see tonight. Those are the streaks of light that we see in the night sky, and they can vary in length and brightness depending on the meteoroid, which is the object that we're not going to see. That's the piece of the grain of dust or particle of rock that's out in space. And these can be anything from pieces of asteroid, leftovers from the formation of planets. Tonight's instance, this is the debris field left behind by this comet that you talked about, Comet Swift-Tuttle. Most of the meteorites, or most of the meteors that we see, are going to be caused by meteoroids that are very small, probably the size of a grain of sand or a pebble at the most. But meteoroids can get anywhere from the size of that grain of sand up into about 1 meter. And if
Wow.
you're at home, the size of a meter is about the distance of your elbow to your index finger. That's the ancient unit of measure that we call the cubit. So anything larger than that we would consider to be an asteroid. So the meteors are generally pretty small. If the meteor is large enough, not a grain of sand, but let's say a rock-sized object that survives its passing through the atmosphere and hits the ground, then we're talking about something that we call a meteorite. The meteorite is the actual piece of meteoroid. It's made it through the atmosphere, didn't burn up, and has made it to us here on Earth. So.
Okay, so some of the meteor monitoring networks, they're actually using different cameras in different locations to triangulate the trajectory of some of those larger ones so that the actual meteorite hunters kind of pin down an area where they can go and hunt for these things. But Keith, where does the word meteor originate from?
Well, the meteor is an ancient Greek word that means something that's happening in the atmosphere. That's one of the common definitions that we hear of the word. So words like terms like meteorology, we would think, or the study of meteors, they are. That's the study of things that are happening in the upper atmosphere, which is weather. Meteorites and meteors and meteoroids are things that are in the realm of astronomy. I always understood the word as meaning suspended rock, which is what the Greeks understood it as.
Ah,
And I
okay.
find it really interesting that, 2,000, 3,000, 4,000 years ago, they understood that there's a relationship between this streak across the sky and these pieces of rock that were very different than Earth rocks, very heavy, usually very dense. And we even have in culture today a monastic community that is called Meteora, which are these buildings built on these very, very high suspended rocks. So part of Greek culture does also include not just something happening in the atmosphere, but also this idea of suspended rock.
Oh,
So that's where we get the word from.
I love all of that. So, I'm going to ask you about, back to the facts today about meteor showers. But
Yep.
before I do that, you were mentioning these meteorites. Now, there's an awful lot of this stuff that kind of gets down to earth, isn't there?
Yeah, a lot. Now, you were talking just a minute ago about the debris field. So there are ways where we can plot the trajectory. And what a lot of people do is they'll plot what they think the angle of attack was. And they'll go out with metal detectors because most of these objects are very heavy, very dense relative to their size. Just to give you an idea, a meteorite that I saw for sale not that long ago, the size of a soda can, which we think 12 to 16 ounces, actually weighed over 20 pounds. Uh,
Wow.
so they're very, very dense. Even the small ones are very heavy relative to their size. As far as finding these, once we see something that we call a meteor burst, you can pretty much go and plot out where, again, you think that these objects are. Classic example was the meteor burst over Russia a couple years ago,
Yeah.
Chelyabinsk, where you can see a map of the debris field where we know pretty much where the airburst was, the meteor burst, and we can see the debris trail and then the mother lode, the large piece of meteor that survived, which fits in the back of a pickup truck. So yeah, you can plot out these, and there are many, many, many of these objects, on the surface of the Earth. The estimate 48 tons falling, raining down upon the Earth
Wow.
per day. Most of them very small, not even grains of sand. There is a saying that if you go up on an average roof and you sweep the roof, you will find what we call micrometeoroids meteorites, where they can be very, very small. So the grain of sand will burn up, but the objects that are a little bit larger do survive. And I would guess that the majority of those 48 tons are these micrometeorites, very, very small, but
Now we're
just a
going to
lot
talk.
of them.
We're going to talk to Dr. John Bovet, who's SLU's Director of Curriculum later. He's going to tell us all about comets. And we're mentioning all of this comet stuff coming down to Earth. There's very complex material in comets, and we kind of think that they may have been the building blocks of life that were delivered to Earth, 4.5 billion years ago. But anyway, let's get back to tonight. I haven't seen a meteor yet, but I have now gone full screen. So do excuse me, Keith, if I'm looking away from
Okay.
you when you're talking. I'm going to be peeled to what we're looking at here. But let's go back to basics. We now know the difference between meteorites, meteoroids, and meteors. But what then is a meteor shower?
So meteor shower is when we see a whole bunch of these at one time. The rate will vary. So for um, the shower that we have tonight, estimates anywhere from 60 to 100 per hour, depending on the conditions. So we do have the waxing gibbous moon that you talked about, but I watched a live feed last night. I saw a ton of meteors, so I'm not going to put too much
Hmm.
weight on the full moon here. Um, so the meteor shower is when we pass through this dense field of debris. In this instance, it's the debris field left behind by the comet Swift-Tuttle, and we're going to pass through that, and we come out the other side. So the meteor shower has been visible for quite a while now. Yeah, at least the last couple of days, certainly almost a week or two. I know that people have been watching
Yeah.
this, and it will be good for the next couple of days. The peak is
Yeah.
tonight. This is when we think that we are passing through the most dense field of debris,
Yeah.
and this is the night that we think we can see the most of whatever it is that's out there as we pass through this debris field left behind by the tail of the comet.
Yeah. Now, Keith, I said this is one of the most popular meteor showers, and it's not just about the number of meteors that we normally see during the Perseids, but it's mainly really about the time of year because there are other meteor showers which have got more, but they're not as favourable to be sitting outside for a couple of hours watching them fall, are they?
Yeah, this is a good one because it is in the summer. We think of the other really great meteor shower, which is the Geminids, or are the Geminids. That occurs in December, so it's winter for people in the northern hemisphere. The Perseids is great because it's regular. We know that every year we pass through in the Earth's orbit around the sun, we're going to pass through this trail of debris. It's in the summertime, so it's not real cold for a lot of us. It's also not very high in the sky. If you go out early, we always recommend that you go out later, just before dawn. But you can also see this really after the sun goes down, and we see different types of meteors depending on when you go out in the night to see them,
Yeah.
depending on where the constellation is positioned in the sky.
And you're
So.
going to be joining us at the end of the show to give us all some tips about how best to actually watch this from our own backyard if viewers are lucky enough to have clear skies. But so we've been talking about meteor shower being called the Perseids, guessing it's named after the constellation of Perseus. But why is it named after a constellation at all?
This is one of my favorite parts of the sky. When we talk about astronomy, there's so much wrapped up in
Mm,
mythology, and Perseus is the classic uh, image in the night sky because Perseus is the hero. So when we look at the meteors that we see, there's something that we call the radiant. This is the point at which the meteors are going to appear to originate from. We're not really going to see meteors coming from that point in the sky, the radiant, which is in the constellation Perseus. It's because the cometary trail as we make our orbit around the Earth will appear to be superimposed upon this region of the sky that we call Perseus. The debris that we see has nothing to do with the constellation. The constellation is the stars in the constellation are probably 4, 5, 600 light years from us. The debris that's entering the Earth's atmosphere are starting to burn up at about 50 to 60 miles above the surface of the Earth. So it's just an accidental relationship where
mm.
we see this debris kind of superimposed upon this region of the constellation. So there isn't really a spatial relationship between the two. It's just an accidental relationship
Yeah.
of what we see.
And all of the meteor showers each year, or the vast majority of them, are named after their constellations and their radiant point. But there are kind of subclasses as well where we're passing through maybe two or three streams, over a period of weeks, maybe. Now, we have mentioned Comet Swift-Tuttle a couple of times so far. That is a heck of an interesting and fascinating object, isn't it?
Yeah, so comets are usually named after the people who first discovered them, and especially on the slew, a lot of times we will see comets that are discovered by sky surveys. So
Mm.
if you ever see Atlas, for example, that's a sky survey. That's basically a computer program that's monitoring a telescope. Here we have two astronomers who in 1832 first observed, or I should say, first documented the sighting of this comet. So it's named after both of them. They were working independently. But this is very common with comet hunters also, where you have people in different parts of the world that are both kind of looking at the same thing and then both get credit. We have to imagine that this comet sort of craze really started back in the 18th century with Charles Messier, who was writing his handbook for what are not comets in the night sky. So we have to imagine just 40 years after him, Swift-Tuttle are actually out looking for new objects that are not in his handbook observed since antiquity. So we know that Chinese astronomers also wrote down, and the Chinese are great when it comes to the sky because they recorded everything. We can go back and we know that this was seen at least twice and recorded and documented by them. Why don't they get credit for the discovery? Because it's only now that we're able to kind of coordinate all the information and data. We would not have known that in 1832 that the Chinese had recorded this, or at least not in the West where we happen to be. So interesting comet. It returns every 133 years thereabouts, and I know Dr. John's going to talk about periodic comets. So the interesting thing here is we've only seen one approach of this comet, so we can't really have a good handle or a good feel of what its path is around the sun. So we almost had what they thought was going to be a collision or a very near collision in the 90s, and they did some recalculations and found out that it was going to miss us, which obviously it did. But we really don't know, and that's very typical of a lot of these objects that we're seeing for the first time or second time. And that's what we have with this comet. We won't see it again until I think 21, 26. So we're really on the first go around with this, but we are passing through the field of
Oh,
debris.
sorry, nice little one there.
Yeah.
I just saw whiz through. So now, Keith, we saw that coming just above where the date and time is there on a downward trajectory. Now, when you're out meteor watching, how can you tell the difference between a Perseid meteor and what we call a sporadic meteor, which is just the normal population of meteors that you can see every night? How do viewers and people watching tonight tell that that is a Perseid meteor?
Yeah, so we actually have meteors that are visible every night of the year that are not connected with the meteor showers that we're talking about tonight. And it's just because there is a lot of debris out in space, dust, pieces of rock. I didn't talk about pieces of planet. We even have pieces of the moon
Yeah,
and pieces of
Mars.
Mars that are floating
Yeah.
around. So not even asteroids. We have planetary debris.
Mm.
Uh, uh, so. what we do is when we look for the Perseus, we're in that part of the sky where Perseus is. We're looking for that radiant, which is off of EE, which is at the very tip. Here we're looking at just the sky that we have here. This is the Big Dipper or the Plough for our European friends. And if we go up right at the top of the screen, we see Polaris. Just to the right, not in the screen, is where the constellation Perseus is. So if you're looking in the northeastern part of the sky, you can pretty much rest assured that you are seeing one of the Perseids. You're seeing part of this debris from the comet. If you're looking the opposite of the sky or in a different direction, those are probably just random pieces of space rock or dust that's burning up in the Earth's atmosphere, not related to the meteor shower per se.
Which is still pretty cool to see. When I'm at our flagship observatory at the Institute of Astrophysics of the Canary Islands, 8,000 feet altitude, 2,000 meters above sea level. After I finish my night's work, I always sit on the car bonnet and I give myself maybe 20 minutes just to chill, looking up at the sky, trying to capture, spot a few meteors. And I'm normally successful, but the problem is meteor watching can be quite addictive. So I see one and I think, oh, that was great. And I think, I'll just wait for one more. And then that goes on normally for an hour or so before I then turn in. So, Keith, before we move on to the next segment, I've got one more question for you. When reading and hearing about meteor showers, sometimes the term fireballs and bolides are used. What are those, and is there a difference between them?
Yeah, so when we see the normal meteors that we see tonight, we're going to see these short bursts of very, very bright, intensive light. Those are usually smaller particles. Occasionally, we will see a very bright streak, and that's what we would call a fireball. A lot of times, a larger piece of space rock that's entering into the atmosphere. We also have to think about the trajectory of these objects as they enter into the Earth. If they're coming in at a very, very steep rate of attack, they're going to burn up very quickly, regardless of what size they are. But if
Mm,
they enter at a very oblique angle, kind of just skimming into the atmosphere, they will burn a little bit longer and give us that very bright fireball with the long streak that we see across the sky. If
mm,
that fireball happens to break up into little pieces, usually which we can observe, then we have a bolide or a bolide. That's where we have the fireball that actually breaks up into small pieces that will fall to the earth, usually as meteorites. Another
mm,
thing about this meteor shower that's interesting is that we also get to see colors with this meteor shower. That has to do with the composition
mm.
of the meteor. So we can expect to see maybe some greenish streaks, and that proves the existence of magnesium in the core, not just iron, but some other uh, chemical components that will give the meteors some color. So we
Yeah.
have that to look forward to as
That'll
well.
be that'll be cool to see. Now, Keith, you're going to be back later to share some of your top tips on how viewers can watch the meteor shower tonight from their own backyards. But thank you as ever. It's enlightening, and I've always learned such a lot from you. So thank you very much for that. Thanks, Keith.
Thanks. Enjoy the
Uh,
show.
yeah, we'll see you later. Now then, before we move on, I would like our producer Gretchen to remind us where this feed is coming from. So, what have we got, Gretchen, here?
Hey, so this is the feed from Mark McIntyre in Oxfordshire in the UK. And he's the tech lead for the UK Meteor Observation Network. So we're super happy to be sharing his live feed.
And what other feeds have you got up? Because I know you've flashed a few up there on
Yeah,
our
I
screen.
have
So,
one from Northumberton. This is their meteor, but right now their meteor feed is obviously of the moon.
and so this is one tip that we'll give people now. You know, if you are lucky enough to have clear skies tonight, don't be looking in the direction of the moon. It's going to be fairly low from northern hemisphere for most of us. But you can just see the difference in brightness. We can see all of the brightest stars. We can see some faint stars there, but in this feed, nothing. Now, they are very different cameras that we're looking at here. So this is a color camera. So we would see, if we saw a meteor in this feed, we would see the color that Keith was talking about. But if we go back to Oxfordshire, then this is a monochrome camera. And the meteor observation networks, they use monochrome grayscale cameras like this because those are far, far more sensitive than color cameras. So that's why they're using these. So they should pick up some of the faintest. Gretchen, I spotted one while I was on with Keith. Did I miss any?
Well, you did. I'm sorry to say, I always want to white lie it so that you don't feel bad, but I did see a few. Down in the corners, actually, is where I have been kind of seeing them. But I've
Okay.
been hoping for another fireball that we saw earlier.
Yeah, that was good. That was good. We definitely need one of those before we end the show, but we've still got half an hour to go. So I reckon it's time to welcome our next expert guest. He's Director of Curriculum here at SLU, and it's Dr. John Bovet. John, can you hear us? Are you there?
Yes, I can hear you and
Hey, John.
enjoying. How's it going?
Very well, very
Uh,
well. We got some great clear skies here. So we did have some other feeds as well lined up, but they're unfortunately clouded out. But this one's pretty cool, isn't it?
oh, it is. It is. I've just been scanning the skies and looking forward to seeing some of the fireballs like we saw right before we got jumped on the show.
I know.
Oh, just saw another one.
Oh, did you? Oh, I looked away. Why? Look, I don't follow my own advice, do I? It is guaranteed when you are meteor watching with other people, and having a meteor watching party in your backyard is great fun. But you can guarantee it that you'll look down, you'll take a sip of water or a cup of tea or something like that, and then you'll suddenly hear everybody else say, "Wow, did you see that one?" No, I have my head down. So, one of the tips as well is just to lie on a garden chair, reclined, and then you're just looking up and maybe use a straw. Actually, there's a good tip. I hadn't thought of that. A straw so you can still be looking up. Anyway, John, we are here to talk about the objects that cause some of these superb meteor showers. Let's go back to basics on it because I love doing that. What exactly is a comet?
Now, you may have heard comets described as a dirty snowball before. I know I
Yeah.
have a lot growing up, but probably a better term for them is an icy dirt ball. It's a
Okay.
very small solar system body made primarily of ice, dust, and rocky material. Comets formed in the early solar system about 4.5 billion years ago, and they preserve the ancient materials from the solar system formation, so they haven't really changed much since the solar system formed. Most comets spend their lives far from the sun in the icy regions of the Kuiper Belt or the Oort cloud. But when one of those get nudged out of their orbits, it brings them closer to the sun, and the ice in the comet starts to vaporize, creating a glowing coma, a cloud of dust and gas, and often a very long, beautiful comet tail.
Okay, so although we're describing it as an icy dirt ball, there's more parts than meet the eye when it comes to a comet. When it's further out, maybe in the solar system, when it's not so close to the sun, it's not creating all of these other elements of a comet. So, what parts are there to a comet?
There's four main parts of a comet. There's the nucleus, which is the solid, you think of heart of the comet. They're typically about a few kilometers to about 60 kilometers in diameter.
Wow.
This is where all of the ice and dust are packed together. The second part is the coma. The coma is a cloud of gas and dust that forms when the sun's heat makes the comet's ice turn into gas. And the comas can be anywhere from tens of thousands of kilometers wide. And there was actually one seen in the early 1800s was the coma was supposed to be about the same diameter or about of the sun, which I think is incredibly crazy to think about they
Wow.
could be that
Yeah.
big. The third is the ion tail, and the ion tail is a bluish tail of charged particles or ions that's blown straight away from the sun by the solar wind. And these ion tails can sometimes be about can be very long, maybe about 3.8 AU. And just to remind us, 1 AU is the distance between the Earth and the Sun. So ion tails can be very large. The
So
fourth one,
go on.
sorry,
Sorry,
go
John.
for it.
Carry on. No, carry on.
The fourth is called the dust tail, and this is
Okay.
a curved yellowish tail made from small dust grains that are being pushed away by the sunlight. See, as the ice is blown away from the sun, sometimes within that ice is dust, and that dust kind of flies out from the tail as well.
So I've heard a term when we talk about comets and the coma of a comet. You were saying that's cloud of gas and dust. I've heard this word sublimation introduced when we talk about comets. Can you explain what that is?
Yeah, definitely. So sublimation is a process where a particle or something goes from solid directly to gas. So it skips
Okay,
over that liquid phase.
right. Okay, so that's what's happening in the nucleus. The sun's heat is heating it up and it's sublimating straight into a gas.
Straight into a gas. And what's
Wow.
crazy about these tails is the tails are in an opposite direction of the sun.
Yeah.
So, I think sometimes when you look at a comet, you may think, immediately think of like a rocket where you see this exhaust coming from
Yeah.
below the rocket, but that's actually not what's happening with the comets. The
Yeah.
tails are moving away from the sun. So when a comet's kind of, passes the sun and is traveling back out to the outer solar system, the tails are kind of like pointing in the same direction that the comet is going, which it seems weird, but that's what's going on.
So you mentioned a couple of places where comets come from earlier. Can you tell us a bit more about those?
Yeah, definitely. There's two main places. The first one is called the Kuiper Belt, and this is a disc-shaped region that's just beyond the orbit of Neptune. It goes from about 30 AU to 50 AU, and
Sorry,
actually this is
John.
also
What's an AU?
and again, an AU is the distance between the Earth and the Sun. 1 AU is
Okay.
the distance between the Earth and the Sun. Copernicus didn't know what the actual distance was between the Earth and the Sun, so he said, well, the distance between the Earth and the Sun is an astronomical unit's worth of distance, and that term has stuck ever since. Um,
Excellent.
What's cool about the Kuiper Belt is Pluto's actually a part of the Kuiper Belt. This is the reason
Oh,
why Pluto's not a planet. It hasn't cleared its orbit because it still travels within the Kuiper Belt. And so comets that originate within the Kuiper Belt, they have a pretty short period. So it takes about maybe 200 years or less for a comet to go from the Kuiper Belt around the sun and back out to that region. And so we call those short period comets.
okay.
The second place that comets originate is called the Oort cloud. And the Oort cloud is a giant shell, spherical shell of icy objects that surround the solar system. And the Oort cloud the beginning of the Oort cloud is about 2000 AU away from the sun, and it actually extends all the way out to about 100,000 AU from the sun. So
Wow.
some light years away. And comets that originate from this area take thousands or even millions of years to orbit the sun. And so those are called long period comets.
Okay.
And so these icy dirt balls are perturbed from their orbits in one of these two regions, and they start just cruising into the solar system. It's actually kind of funny. My daughter, my 8-month-old daughter, I read her this book all the time called The Little Comet, and it follows a journey of a comet from the outer solar system into the inner solar system, looping around the sun and traveling all the way back out. It's really
Brilliant.
fun that
I
that
love
kids
that.
are learning about this stuff.
I love that. I love that. Now, John, although we want to keep on the live feeds as long as possible, if you do have any slides that you want shown, please just ask Gretchen and she'll pull those up for you because I know a picture paints 1,000 words with some of these concepts. But now you've mentioned the tails, we've mentioned sublimation. Why do they develop these tails?
So they develop the tails because the comets are getting heated up from the sun. And so the comets don't always have that tail. The comets need to get, close to the sun in order for the sublimation to start happening. And so, how close, you may wonder? Well, about just inside Jupiter's orbit. So, once
Okay.
a comet gets there, the sun's heat warms up the surface, the ice on the comet turns directly to gas, skipping that liquid phase, doing the process known as sublimation.
Right.
And dust trapped within the ice is also released. So we get the ion tail, we get a dust tail, and the solar wind and sunlight push that gas and dust away. So even though the nucleus might only be a few kilometers across, those tails can stretch for millions of kilometers, which
Yeah.
is pretty amazing.
It is. Slew members have captured some absolutely epic comets over the years, and there's been a recent one that some of the students have been capturing, and as you say, that just actually looks like a slightly fuzzy star, and they've been animating it in one of your quests, in the animation module, which is pretty cool. They captured a whole series of images and they put them together and they've turned it into an animation, and there's no discernible tail on this comet at the moment, but as it gets closer to the sun. We're always hopeful. I think everybody who's interested in space and astronomy, there have been so many great comets. Oh, this year we're going to have the greatest comet ever, and they turn out to be a damp squib, don't they? So, and that's the thing, they always surprise us. Comets. We have no idea what they're going to do next. Now, we covered this in the last segment, but can you tell us again, how are comets connected to meteor showers?
Yeah, so as comets are moving through the solar system, that tail is being formed, and that those dust particles from the dust tail get left behind. You could think of it as comet tail debris or comet tail exhaust if we want to think back to
Mhm.
to the rocket anti-example of a tail. So over time, those streams spread out along the comet's path. And so when the Earth's orbit crosses one of those streams, those tiny particles enter our atmosphere at high speeds and burn up, creating those meteor showers and the hopefully we get to see some fireballs from some of the bigger dust particles that are there. And that's basically what's happening tonight with the Perseid
Yeah.
meteor shower.
And you mentioned two types of comet. You've got the long period comets, you've got the short period comets. It's these short period comets which are responsible for these, aren't they? Because they're returning to the inner solar system quite often. And actually, over a number of hundreds and thousands of years, they can build up quite dense trails. And as we were saying before, they can be quite separate. And that's what a lot of scientists try and forecast, and they're doing that through meteor observation to tell where the densest streams of this debris are left. I mean, it's a fascinating. Wow!
Whoa!
Woohoo! That's the best one I've seen yet. I was actually looking at my screen. That was a good one, John, wasn't that?
That was fantastic. That was better than
Okay.
all the ones we saw before, I think, too,
Okay.
before the show.
Yeah, I would say that
Oh,
is, and a
oh,
small one as well. Oh, this is good. This is good. So Perseids are always better. They get better and better as you go through the night. We'll give you some tips on that later on, but I'll share one now, and that is with the Perseids, it's actually a meteor shower where it's better to get up earlier in the morning when it's still dark rather than stay up late because you get more meteors before dawn. So there's a little tip for you. But that was I think that's pretty close to being a fireball in my eyes. So that was a good one.
oh,
So,
for sure.
and what we don't see with the Perseus so much is sometimes you can get a persistent trail on some meteor showers, and this all has to do with the composition and the size of the grains as well of that particular comet, and therefore the debris that's left. But let's get back to them then, John. Have we're all into space travel now, and this burgeoning space industry is absolutely amazing. Have humans ever visited a comet?
Yes, we have. If Gretchen,
Wow.
if you could bring up my slide 4, to show us the European Space Agency's Rosetta mission became the first to orbit a comet, Comet 67P Churyumov-Gerasimenko, and it even deployed a small lander called Phaley. And I actually I remember when this happened. The lander came in, it bounced on the surface of the comet a few times,
Yeah,
and before settling on the surface. So the image on the left is from before it landed, and you can actually see the tail in the distance there.
yeah,
And the image on the right is after the lander landed on the comet. And it's really remarkable because it it looks like it just looks like a mountain wasteland. And that's a comet. It's really cool.
yeah,
So Rosetta studied the comet over 2 years, sending back incredible images and discovering complex organic molecules on the comet, possible building blocks of life. What
mm,
I think is even more cool is SLU's Comet Monitoring Club was a major contributor
yeah,
of ground-based observations of the comet to the ESA's Pro-Am program. So SLU members submitted the most extensive set of ground-based data to the ESA, which helped them plan how Rosetta could actually get to the comets,
yeah.
which which is so cool.
And
Um,
really important because one of the things they wanted to do with that mission is to almost calibrate the ground observations of comets to what was really there. But that image, John, I mean, we were quite surprised by that because this thing turns into not this, kind of solid icy dirt ball that we were describing. And I think a lot of us would think of a comet nucleus as probably being quite spherical. But in
mhm.
fact, it looked more like a giant peanut. And we think it's possibly two lumps of this material that came together, don't we?
Oh yeah, definitely. I mean, the it could even be that these two lumps of material crashed into each other, and that's
Mm.
what perturbed its orbit and actually started it cruising into the inner solar system.
Okay, so it could have been out there in the depths when all of this. I always think of comets, the Oort cloud and the Kuiper belt, kind of being the leftover construction material of the solar system, the stuff that didn't get together in time and now is just dispersed out there. But as you say, you know, sometimes stuff happens out there and it sends one of these objects into the inner solar system. I want to point out something on the live feed at the moment because tonight, if you're out in your backyards meteor watching, there are several objects that you might confuse with meteors. We've seen a little flashing light going very slowly from the right hand side of the screen. It's now bottom left. If you see a flashing light like that, you know it's an aircraft. If you see a slow moving white light, which is not blinking, you're probably seeing a satellite. And unfortunately, for astronomers anyway, there are more and more satellites up there. And when you're trying to do some research with SLU's telescopes or capture some beautiful images, sometimes you'll get one of those passing straight through the frame. Some people think it spoils the image. It does if you're doing some research. But actually, John, I quite like a satellite going through one of my SLU images because it shows it's live astronomy that I've scheduled the telescope. That's my mission. It's not some image from NASA or Wikipedia or something. It's live astronomy, and that's what happens. We have strange observing conditions sometimes, don't we?
Yeah, yeah, we do. I mean, I admit that I use some of my images that had some satellite streaks in it in my quest because I know that
Yeah.
those are kind of, super personal to my journey of
Yeah.
scheduling missions.
Absolutely, and it's your image that you captured. You controlled that mighty half-meter telescope in Australia or Chile or the Canary Islands, and you captured that data. Now then, here's a weird question that we've had from a student, John. You ready for this?
Hit me.
Do comets smell?
It's a funny question. If it's strangely enough, they do in a way.
Really?
Scientists studying data from the Rosetta mission found that Comet 67P's coma contains chemicals that smell like rotten eggs. So this is
Nice.
hydrogen sulfide, uh, cat urine, which is ammonia, and bitter almonds, which is hydrogen cyanide. So
Okay.
if you could smell a comet, which you totally shouldn't because it's totally toxic for us, you definitely wouldn't forget it.
Okay, I'm going to cancel my holiday that I've booked to to a comet. That doesn't sound too appetizing. Now, I'm going to take you off piste here a little bit because We're launching something very soon at SLU. It's called spectroscopy. And you were just mentioning there some of the compounds which we believe comets contain. What
hmm
can students do if we get a really nice bright comet? What can students do with our new spectroscopy system to learn more about the composition of comets?
Well, if they take a spectra of a comet, the comet spectrum is like its chemical fingerprint. So by splitting the light into of the comet into its individual colors, we can identify gases and dust particles that are present in the comet and the tails. So different molecules absorb and emit specific wavelengths of light. And so by seeing the light that's emitted from the comets, we can match them with known substances and determine what's there. So it's almost like matching a barcode to a product.
Okay. Oh, that's going to be. We need a decent comet, don't we, so that we can test the new spectroscope on it. And we've already actually made some sample data from when I was installing that system a month ago. We've made some sample data available, and some analysis software as well called RSpec from our lovely partner Tom Field. So that's going to be an exciting one, isn't it, John? Hopefully, you've
Oh,
got some
yes.
Quest learning activities planned for it.
Yeah, definitely.
Okay. So we talked about, what these things are. So we've said, you know, icy dirt balls and stuff like that. We've said they're made up of, some fairly complex compounds here. So these things have got ice, which is water. Did they bring water and maybe life to Earth, as we suggested earlier?
It's a possibility. Some scientists do think that comets may have delivered part of Earth's water and maybe even some of the organic molecules that help life get started. It's an idea called panspermia.
Okay.
Um, and so but it's still highly debated. So measurements of the type of hydrogen that's in comet water, the H in the H2O in the comet water doesn't always match the same hydrogen that we see in Earth's oceans. So it could be that asteroids played a larger role, but comets could still be part of that story.
Okay. Okay. And you can imagine the early solar system when it was utter chaos. I mean, the sky was probably full of comets. What a time to be a cometary scientist back then, if it were possible. But anyway, so next question. You mentioned asteroids there, and we know that we've had asteroid strikes on Earth. We've got our A team, a near Earth object monitoring team of members at SLU who track and monitor asteroids, near Earth asteroids, comets. Are they dangerous to Earth? Are comets dangerous to Earth?
They're mostly harmless. Of course, if a comet did hit Earth, it would be catastrophic. But because comets often travel on these long looping orbits, they can be hard to spot in advance. So astronomers and on SLU, we keep trying to keep an eye on where the comets are and look for them carefully. But the good news is there isn't any known comet that's on a collision course with Earth for the foreseeable future. So.
I like
That's
the
great.
I like the terminology that used any known comet. So let's cross fingers. So at the moment we're just being pummeled by the debris. Oh, that was a nice little one just above the clock, John. I don't know if you saw that one. Yeah. Oh,
Beautiful.
we've seen some good meteors tonight. That's pretty good going. Now,
hmm
talking about danger to Earth, that brings up an interesting question as well. What is the difference between a comet and an asteroid?
Yeah, it's a really good question. These small rocks that are floating around in the solar system, what's the difference? Well, it's mainly the composition. So asteroids are mostly rocky or metallic, and they formed closer to the sun, so they don't have much ice on them. Whereas comets formed further away, so they're both icy and dusty. So
Right.
one of the main like giveaways for if you're looking at a comet or a an asteroid is comets grow a coma and they have tails when they get near the sun, and asteroids don't.
Yep. But we have actually seen over the last 2 decades, we've seen some objects that kind of fall between the two. Asteroids that maybe show a little bit of cometary um, activity, and we're thinking that maybe
Hmm.
those are kind of the remnants of that cometary nucleus, and all of that volatile material has left it through those repeated journeys that you were talking about around the sun.
Yeah, definitely. There's even I think there's even been some comets that you can see coming in, but they lose all of their ice by the time they go around the sun, and you just don't
Yeah,
see the tail anymore.
yeah,
And yeah, repeatable motions. These comets are just slowly losing their debris,
yeah.
turning into these beautiful debris fields that the Earth can go through.
And of course, some of them don't actually survive even their first journey around the sun, do they? Because with the new space telescopes, which are dedicated to observing the sun, we can see comets in there approaching, and as they go around the back of the sun, some of them don't appear back, or if they do, they've maybe fragmented into several larger pieces. So, John, how
Yep.
bright can comets get? I think I just saw another meteor out of the corner of my eye there. But how bright can comets get? Because we sometimes talk about the great comets of our time, but you know, what have
Yes,
we seen?
some comets can get bright enough to be seen with the naked eye, even from cities. There's some rare great comets like the comet Hale-Bopp in 1997,
Yeah,
or probably the most famous comet of all, Halley's Comet, which last time it was around was in 1986, or the comet Neowise, which it was
yeah.
in 2020. Gretchen, if you could pull up slide 5 just for a moment, these
Oh, yeah,
comets are
that'd be good.
spectacular and can be visible
Wow.
for weeks and months. Most comets are faint and require a telescope to see, but we were able on Slew to capture this comet, Comet Neowise, back in 2020. This was when it was on its closest approach. This is probably one of my favorite. This is probably one of my favorite comets, but also probably one of my favorite snaps on Slew too. I was just so taken by this.
Yeah,
And I can remember back in 2020, my wife and I were able to go out like just outside of town a little bit, and we saw a Neowise in the sky. And I mean, it was took up a
yeah,
nice chunk, but you can totally see it with your naked eye. It was
yeah.
amazing. My
We
first
need it.
comet.
We definitely need another one of these. And the glorious thing about Neowise is that you could watch the changes in the tail almost, every hour. So we can see in that image, you've got the a dark streak going through. Well, that would sometimes change. We also see these tail disconnect moments where maybe the solar wind actually just blows the tail so hard that it actually disconnects before it can send out a new stream. But we can see the color there as well, John, and we've already talked about the spectrum, so we won't go into that anymore. But imagine a comet like this when our new spectroscope is operational in the Canary Islands, which is going to be very soon, by the way. Now, let's move on. We did talk a little bit about using that instrument. But what kind of gases do you think we're going to be seeing in those comet spectra when we get them? Oh, another one straight
Ooh,
down by the
another
clock.
one.
That was another good one, wasn't it?
Yeah,
Wow, that little
yeah.
corner seems quite a little hot spot.
It does. So if we were to look at comet spectra, some common gases we may encounter are, of course, water vapor, H2O, but we'd also see some other things, carbon dioxide, CO2, carbon monoxide, which is just CO, and some various cyanide components such as CN. These produce distinctive bright emission lines that we'll be able to clearly see in the visible spectra that we'll have on SLU here pretty soon. But we'll also see some diatomic carbon, which is
Yeah,
C2. And this often appears as a green glow when we look at
yeah,
comet images. So that's one of the reasons why comets appear green in photographs. It's very rare to see green things in the
yeah.
sky. And comets are one of those. Planetary nebulae are another ones, but that's a story for another day.
Oh, I think I saw another one out of the corner of my eye. Why is the dust part of the comet important in the spectrum that we're going to be collecting?
So what's interesting is dust doesn't emit light like gas does.
Mm.
Gas emits specific wavelengths of light, whereas dust grains are pretty big, and what they basically do is reflect the sunlight. So when you take a spectrum of a comet, you'll have a background spectrum, which is from the dust, and then you'll see these little spikes coming up from that background spectrum. And so the spikes are from the ion tail, and that continuous background spectrum is from the comet tail
Okay. What can
or the
spectra,
dust tail. Sorry.
sorry, John. What can comet spectra then tell us about the early solar system? What can we learn about that? Because we've already said that, this is the remnants of the construction, really, of the solar system. Can they tell us anything about that?
Oh, definitely. So, what beautiful thing about spectra is it allows us to identify particular compounds that are within the comet. So,
Woo!
whoa, that was
Best one yet.
massive,
Best one that was
massive.
beautiful, wasn't it?
It
And we know
was.
that that's a Perseid because it was emanating from that radiant point that Keith told us about in the constellation of Perseus. Wow, that was a good one.
That
Sorry, John,
was.
to interrupt.
Oh, it's okay. It got to for something that beautiful. So comets are made of the material that's been stored in the cold outer regions of the solar system for billions of years.
Hmm,
Like your analogy earlier of the construction material left behind, or I like to think of like when you're baking a cake or making something, some of the ingredients get on the countertops. It's almost like that. So the spectra reveals the original mix of
yeah.
ices and dust from when the solar system formed. So by comparing comet spectra to each other and comparing those spectra to those of asteroids, we can gain insights on how planets and small bodies in the solar system formed and how the materials were distributed and how the materials have changed since they
Oh,
coalesced into the planets and so
it's a
forth.
fascinating area of study, isn't it? And we can tell all of this just by looking at the light and analyzing the light from these objects. Now, before I let you go, John, here's another question for you from a student. What is the coolest comet fact you know?
The coolest comet fact I know, so probably one of my favorites is about Halley's Comet, which I mentioned earlier is probably the most famous comet of all.
Yeah.
Humans have been recording Halley's Comet for over 2,000 years. The ancient Chinese, the Babylonians, the medieval European astronomers, they all saw it. And they all, most of the time thought it was some kind of omen, whether good omen or bad omen, most likely a bad omen, but it's the only known short period comet that's regularly visible to the naked eye. It returns every 76 years. So the last time it was around was in 1986. I missed seeing it by 1 year. So the
Oh,
next time it shows up, it will be 2061. So I've literally been looking forward to seeing Halley's Comet for my whole life, and I can't wait.
okay. That is a very cool fact, but could be depressing because I'm not sure I'll be around in 2061 to see that one, John. But I wish you and your daughter well in your observations of Comet Halley. That will be really cool. So thank you, John,
Definitely.
very much for sharing your superb knowledge this evening. And hopefully, have we got any comet quests planned? That would be cool, wouldn't it?
There is a quest all about Halley's Comet that's on the drawing boards.
Okay.
So so keep an
Okay.
eye out for that. I don't have any time frames for it yet, but it's on my list.
That'll be cool. That'll be cool. And you'll have to accelerate that if we suddenly get one of these expected kind of epic comets discovered. So thank you very much, John. You
Absolutely.
take care. Thank
Thank you
you.
so much, Paul. Thank you for having me on, everybody.
Take care.
Enjoy.
Now, what a great segue. John was talking there about Halley's Comet, being recorded 2,000 years ago. Well, my next guest, Milton Villarreal, he's a SLU educator and archaeoastronomy, and he's going to join us now to tell us a little bit about how ancient civilizations saw and reacted to meteor showers. Now, some of you will already know Milton because Milton has been doing a whole series of space science classes in Spanish. Milton, can you hear me?
Hola, Paul. Yes, of course, I can hear you, and I hope everybody can.
Hola,
It,
yeah, we can hear you loud and clear. Love your backdrop as ever. So, how are you? Did you enjoy
I'm all
doing
right.
did you enjoy doing the Spanish space science classes? They were terrific.
Oh, I cannot describe how much I did. It was an absolute challenge for me, but SLU helped me throughout the process, and it's already out there. So I hope
Yeah.
our Spanish audience will enjoy it.
Yeah, well, you're a very engaging educator, if I may say, and any Spanish-speaking students out there, those are all available on SLU's website on demand. So if you miss them live, you can go back and peruse them at your leisure. So, Milton, I mentioned that you're an archaeoastronomer there. Can you tell us what archaeoastronomy is? Because it's a bit of a mix of two different terms, isn't it?
Yes, it is, but it's looking in the opposite direction as we normally do. Like with pure astronomy, we are always looking into the future with better telescopes, better
Mm.
technology, looking farther away. But with archaeoastronomy, we look into the distant past. We try to, in a way, learn more about our ancestors, but we are also learning about the incredible ways in which they could figure out the skies. And
Yeah.
that's fascinating to think that people were looking at the same sky, let's say, 1,200 years ago, for example, in the case of the Maya, and how they tried to give answers to all these phenomena is incredible.
So you let's go through some of these ancient civilizations, and you mentioned the Maya there. As you say, they were expert astronomers who tracked celestial cycles with precision, had beautiful calendars made. How do you think they might have interpreted the sudden appearance of meteors? Were they seen as divine messages or disruptions, maybe, to their cosmic order that they were trying to record so carefully?
Definitely, definitely. We know that the Maya watched the Perseids. They didn't call it that way because that mythology
Okay.
belongs to another culture. But what they did see is recorded in some of the codices they left, and trying to match what they left with, what we believe is the Perseids' view is what's fascinating. It's like trying to solve a Rubik cube squared, really, because
Yeah.
they believed in a
Well,
long. Oh, that was a great one.
it was a good one. Yeah,
They believed
carry
in a
on.
long count calendar, and they also had shorter versions of it. And to match those, the way they calculated time to the regular appearances of this, meteor shower is incredible. So we know they saw it, but their interpretation is right behind me. For example, the
Ah,
Maya person that you see behind me is looking at the view of a snake. To them,
okay.
these long shots in the sky were army of snakes coming down to Earth, and they could be positive or negative omens. They could be reinforcing their armies, or they could be invading armies that could be coming, to conquer them. So they really
Wow.
kept an eye on the sky for that.
So, do you think some of their observations of meteor showers would have triggered specific ceremonies or offering to appease the deities if they thought this was, something invading, a bunch of snakes invading them?
I am pretty sure. I'm pretty sure. And knowing about them beforehand, as they tried to do with all their predictions, was probably part of the secret of keeping, the imperial class always on top of the society. Information back then was precious, and as it is today, let's say. But for them, it meant keeping the whole empire, standing.
So, Let's move on to another culture here then. If we talk about, and you've talked about this in previous star parties, which I always love to hear. Aztec mythology. Now, they believe
Mhm.
that the gods were deeply involved in celestial phenomena. Could the Perseids have been viewed as sparks from the weapons of gods or the signs of cosmic battles to the Aztecs?
Yes, let's remember that the Aztec inherited a lot of the record keeping of the Maya. And of course, with their own calendar, they try to figure things out in the same way.
Mm,
Now, for them, for the Aztec in this case, uh, those, bolides, as we call them, were spears from the gods, right? So for them,
okay.
anything that disrupted that, regularity of the sky was something, a message from the gods. And they also thought about rituals that would realign the cosmos to what originally was.
Wow. Now we're going to skip through a couple more here because we're already running over time a little bit. But while we're seeing some great meteors, why not? Um, Incan cosmology. Now you've spoken about this before as well. The Inca revered Inti, the sun god, and closely observed the heavens. Now, might meteor showers have been seen as omens for them, and in what way?
Uh, well, let's make a difference clear. Comets, for example, were bad omens for them.
Right.
But meteor showers, in many ways, pointed at some agricultural cycles. When, for example, they saw some of these, they thought this is the rain from above, from the gods, let's say Inti in this case. And that meant, better products, a surplus of products. It was actually signaling a very good year for them.
Okay. So you have previously talked about the way the Inca connected celestial events to sacred landscapes and things like that. Could the Perseids have been linked to specific geographical features or temples as, I don't know, as places of divine descent or something like this?
Yeah, that's absolutely for sure. In the same way, we associate these Perseids to our constellation of Perseus. They also associated the point where this came from with what they call wakas.
Whoa,
There was another
lovely
one.
one.
And one of the most powerful wakas or ritual places for them was precisely where the Perseids came from. So this was a way of their gods to contact them and tell them, for example, that this was going to be a very good, uh, fruitful year in agriculture, for example. There are The Inca did not leave a lot of anything written records like the other cultures did,
Right.
but their way of recording things definitely show that they would count, more production right after a meteor shower, for example.
Wow. Thank you for that. Now we're going to move on to some of the best record keepers. You were talking about keeping records. Some of the best and earliest record keepers, of course, were the ancient Chinese. Now, they weren't astronomers back then. They were astrologers, Chinese astrologers. They documented the Perseids, didn't they? As early as, didn't I think maybe Keith or maybe John said earlier, as early as 36 AD. What
Yeah.
role do you think meteors played in imperial astrology? Were they seen as warnings to rulers or maybe signs of heavenly approval?
Well, you probably know that the Chinese believed a lot in balance. And so this definitely disrupted the normal balance of things. And it was an invitation for them to rethink, the ways they were doing and to rebalance things according to new information they would get. So this was a way they could, see that they needed rethinking about certain aspects of their life. And in Confucian thought, for example, the balance between yin and yang and everything, or the shi as they called it, meant that the skies were giving them a message, and that flow of energy needed a re alignment, let's say.
Okay.
It's a fascinating way of looking at the world and the cosmos.
Milton, we definitely need to get you to write some more quests. You've already done a couple, and students enjoy them so much because it's this sky lore and culture and mythology. It brings the heavens to life, and for some students, I know some of the students that came to your classes, to make those connections with what they're observing in the night sky to their own culture and ancient cultures before them from their ancestors really builds that connection. But hey, listen, I've got a big question to finish with. Despite their geographic separation, all of these cultures that we've spoken about, they revered the skies. What do you think the Perseids reveal about humanity's shared impulse to find some kind of meaning in the heavens?
Well, just like all astronomy, it joins cultures to each other, and they are inviting us to search for meaning, new knowledge, maybe new connections, right? You are right. Despite their geographical distribution, all ancient cultures thought about this as communication with something bigger, something, out there. So I think it's the same feeling that still joins all of us, all our audience out there,
Yeah,
uh, around this cozy fire that SLU provides. And we keep our eyes up there and wonder. And that's the magic of astronomy. It really
yeah,
blends cultures together. Right here in the
it
panel,
does.
we're people
Yeah,
from different parts of the world talking about
yeah.
one single topic.
Yeah, you're right. Sharing that awe and wonder that we have when we gaze up, and I'm going to have more of that personally in my own backyard because as soon as we finish the star party, I've already got my lounger out there with a cushion there. I'm going to spend an hour just chilling after the star party, hopefully catching some of these superb Perseid meteors that we're seeing here. Milton, it is always such a delight to have you on our star parties. I always learn so much about from you, and we've got to get some more cultural and mythology quests done. So maybe we'll speak about that
I
soon. But
promise.
thank you this evening. Thank you so much for joining us. Take care.
Well, really, thank you for having me. I'm very humbled to be part of this panel, but very, very happy to have brought this topic to our table. Thank you
Thank
very
you,
much.
Milton. You're a wonderful soul. Thank you very much. Take care. Right, we are nearing the end of the show, and we have got now some top tips for how you can watch the Perseids just like I am from my own backyard in about 10 minutes' time. But we're going to welcome back Keith Wozaleski. Hello, Keith. Can you hear me?
I can hear you, Paul, loud and
Hi.
clear.
Really good. We've seen some cracking meteors tonight, haven't we?
Well, I tell you, the two that you said were the best ones were the ones I missed. I looked away just like you said, you put a jinx on me. Just when I looked away, you and
Ah,
John were, oh, look at that. Well,
oh,
that was a pretty
there was
one
a little
there.
one there.
But
There
yeah,
was a little
I
one
missed
there.
the two. I missed the two fireballs, unfortunately.
Okay. Oh, well, I'm sorry. So, well, you can watch the recorded shows because all of Sleuth Style
There
parties
you go.
are recorded, as you know, and available. So we can see another flashing light going across
Yeah,
there. It's
we got
actually
another
following,
plane.
yep, exactly the same flight path as the last one. So
You're
hopefully
on a
we'll get a,
vector.
yep.
You're on a vector
Hope,
to somewhere.
hopefully we will see a few more while we are talking about how viewers and students can watch the Perseid meteor shower from their own backyard. Keith, give us your top tips for what to do to watch a
So,
meteor shower.
so top tips. I'm thinking in terms of three. So the
Okay.
first of all, and you've kind of touched on two of them. First of all, you want to be comfortable.
Yep.
So if it's cold wherever it is, you want to be comfortable because you're going to be out there for a while. This is not like going out and looking at, the full moon or some other celestial things where you go out for 5 minutes and you come back in.
Yep.
Your eyes need to dark adjust. So you want to go out for about 20 minutes.
Yep.
And you said you're going to go out for an hour. That's an ideal time, unless you want to stay out longer. But that gives you that 20 minute to 1 hour period where you just kind of get into the zone and you sort of get yourself acclimated to not just the darkness of the sky, but also kind of get into that quietude, where you settle down,
Mm.
where you're ready to observe what it is
Oh,
you're going to look at.
what was that? I just saw something on the left. It didn't look like a Perseid though, because it wasn't coming from the right-hand side. So sorry, Keith, to
Could
interrupt.
be, could be. The other thing is you want to take out the most valuable piece of astronomical equipment that you possibly have, and that is called your eyes.
Yep.
Not only are they going to dark adjust, but when we think of our peripheral vision, we don't see 180 degrees, but I think it's like 160, 150 degrees. You can test
Yeah.
this at home. Stare straight ahead and then look when you can wiggle your fingers, when you can start to see them. That's how much of the sky you want to take in.
Yeah.
As I mentioned, you don't really want to look right at the radiant, so you don't even need to know where Perseus is. As
Yeah.
long as you're looking in the region of the sky in the northeast, you should be okay. And you can sort of micro adjust when you start to see objects and get yourself. You definitely don't want to be looking out at the moon. That's in the southern sky. That's totally wrong.
Mm.
Not east or west. You want to be in that northeastern part of the sky. So use a compass on your phone if you have that. Another thing that helps is you don't want to stare at one particular spot of the sky. So I
Yeah.
don't know if anybody's practiced this at home, but I discovered this very early on as a child. You can focus an object ahead of you, and then you can sort of stop focusing and just kind of take in all of your surroundings. That's how you want to go out and observe a meteor shower. You want to take in as much of the sky as
Yeah.
possible, not focusing on a direct spot, but more of
It
an oblique spot.
Yeah, it's very easy, isn't it? And I've trained myself over the years. It's very easy to get absolute tunnel vision and you look and focus on a single star, and your brain is kind of blocking out everything else. Because basically, when you stare at something like that, it's focused and concentrating on that. You almost have to be incredibly relaxed and just try not to focus on any individual object. And one of the things you're talking about, that peripheral vision, Keith, one of the things that always surprises me, and will happen in 10 minutes time, is when a meteor appears in your peripheral vision, your brain and your eyes can react so quickly that you can turn and face it before it's gone. And that always surprises me because, the ones that we've seen tonight, they're up there for way less than a second, probably a tenth of a second. But we're so good. Our brains, especially, are so good at interpreting, those flashes. But other top tips, Keith?
Yeah, just to your point, the eye is an incredible piece of equipment. It's an
Mm,
incredible organism. And if you haven't practiced that shifting back and forth, you will see your vision shift when you're focused in, when you're not. And of course, that beautiful wide field of view. Third, I think the third best tip is exactly what you talked about having set up. Some type of lounge chair, something where you can
yeah,
incline yourself back, because there's
absolutely.
nothing worse in the world than going out with a pair of binoculars or seeing something like this, a meteor shower, and waking up the next day and you can't move your head because you've
Oh,
got a
nice little
stiff
one there.
neck.
Yeah,
It's awful. You've got to be in a
yeah.
position where you've got your lawn
Your
chair,
neck is straight
or
and
even
you're,
just lying on
yeah,
the ground. Yeah, put a pillow behind your back. You
yeah.
don't want to be spending the whole night looking up because you will
Oh,
have a sore neck the
another one.
next day.
Just as you were demonstrating that, Keith,
That's
there was
well,
a
that's what happens.
lovely meteor that whizzed above the time and date again. I'm very sorry.
Oh, gee.
But
Well,
you're absolutely right. And the first couple of years I ever went out meteor observing, that's what I did. I sat in a normal garden chair and I'm got my neck craned up, and it is so uncomfortable doing that. Just recline, maybe 20 degrees, something like that. And actually, I quite enjoy. If I can see a lot of my horizon and maybe surrounding houses and trees, what's the point of having those in my vision when I could be looking at more sky? So quite often I'll be looking almost straight up for a meteor shower, but yeah, absolutely with you on. I think actually staying warm and being on some kind of reclined chair are the two top ones for me. I think The um, dark adaptation of staying out for 20 minutes is also really important. And you can test that as well when you go out, have a look at the sky, see how many stars there appear. And as that 20 minutes progresses, you can see more and more of the fainter stars. And if you can see the fainter stars, you can see the fainter meteors. So, any other top tips there then, Keith, for meteor watchers going out to watch the Perseids tonight?
I think that's the big thing. Most importantly, just go out and enjoy the night
Yeah,
sky. If you're getting up early, that's good. You can also enjoy this right after the sun goes down. Then we see a special type of meteor called Earth grazers because
yeah,
Perseus hasn't completely risen yet. Still be very low on the horizon. That's always kind of a neat phenomenon to
yeah,
do or to witness too. The big thing is go outside, have fun, no expectations. So don't go out there expecting to see how many are counting. Don't use your cell phone. I know there are apps where
yeah,
you can record how many. None of that. You want to just
yeah,
enjoy the night sky.
yeah,
And if you get up early, also enjoy the night sounds. There are all kinds of sounds and smells that we hear during the night that we don't see if we don't go out and observe. And the great thing
yeah,
about it is you don't have any equipment to fiddle around with. All you have to do is be out there and
exactly.
experience. So I think
Yeah.
that's
Exactly, it's and that's the great thing about meteor showers. Slew's got mighty telescopes around the world, but telescopes are the worst possible thing you can use for meteor shower because you're only looking at a tiny part of the sky. Your eyeballs are the best. Don't even get your binoculars out.
nope. You
And
want the
Keith,
whole thing.
yeah, you mentioned the first couple of hours of darkness. That's even more important this year, possibly. You won't see as many meteors in the evening as you will in early morning, but the moon hasn't risen in those first couple of hours.
That's
So you're
right.
going to get
Exactly right.
some
You're not
nice
gonna.
dark skies. So it will kind of balance itself. Just saw another one there as well. Keith, we have said that Perseid meteor shower is best observed. You'll see more meteors in the couple of hours of darkness before dawn. Now, if viewers do that this year, they've got an added bonus, haven't they?
Oh, yeah, they do. They have it's sort of a rare event, a planetary conjunction. So if you're looking in the eastern sky, you will see two stars, basically look like very bright stars. Will be the planets Jupiter and Venus, very,
Mm.
very close together. The actual moment of conjunction, which is when they're sharing the same right ascension, technical term, but they're still going to look very close tonight and for the next few nights. Basically, what's happening is Venus is orbiting the sun faster than his Jupiter and basically is lapping it. If you can think of it being on a racetrack, it's taking the inside track and it's going to pass Jupiter. And it's been visible the last 2 or 3 nights.
Oh,
Very,
nice, yeah.
very close. Very easy to see. Venus is
Yeah.
very bright right now. Jupiter will be the object sort of on top of it, not quite as bright. Totally visible with the naked eye. Again, you don't need any equipment for this to see it. It's a great little reward. And
Mm.
if you're going to watch the meteor shower, I recommend you just stay up all night. It's not fair to get
Yeah.
up early. You've got to stay up. You've got to pay your dues, and you've got to earn this one. And the bonus is seeing this planetary alignment of Jupiter and Venus. So
Excellent. Now,
that's
actually, we were
awesome.
saying, for the meteor shower, don't have a pair of binoculars, but if anybody has got a pair of binoculars, and I've even done this, I've even tested this with, my daughter's play binoculars that she had when she was young. And if you point those to Venus and Jupiter, Venus will just look like a very bright object. But if you look at Jupiter, even with a cheap pair of binoculars, you should be able to spot the Galilean satellites, the moons that Galileo discovered, and you'll see those stretched out on either side of the planet. Keith, do you use a pair of binoculars very much at home, or are you
It,
just a telescope person?
I love binoculars until I hurt my neck, and
Ah,
I was looking. I was in that region. The, the nice thing about this is, when you go out to look for Jupiter, the satellites, the moons of Jupiter will be very small. They'll be very faint. They're going to be subject to atmospheric disturbance, so they may be there and not be there. But if we're in the region of Perseus and you take out binoculars, you've got to go for the double cluster. That's right between Perseus and Cassiopeia. It's one of the classic objects in the night sky, one of our
yeah,
favorite objects here at Slough. So you can do a
yeah,
little bit of extra credit work if you do take binoculars out, but you certainly don't need them.
exactly.
Yeah, certainly
Yeah,
don't need them for the meteor shower. But you
and the
will see
other. Yeah.
Jupiter.
The other
Yeah,
object that's really good for a pair of binoculars is the Andromeda Galaxy as well, which is in that
you got that right there too.
same region of the sky. Yeah,
Yeah, we're in that again, and the beautiful mythology. If you haven't delved into Greek mythology and where we get the names for some of these constellations, this is where you want to start with Perseus,
yeah,
Andromeda, Cassiopeia, Cephas,
yeah,
Cetus, the Kraken, the sea monster. There's so much happening, and it's all
yeah.
right where we are tonight. So
It,
it's exciting
it,
stuff.
that I am the same as you, Keith. You said it right at the top of the show. This area of the sky is my favorite as far as mythology are concerned because they were stories that I knew about from school before I got into astronomy. And there I see all of the characters in those stories grouped together in the night sky. And I love that. And it is a brilliant way, actually, of learning your way around the night sky to associate those mythological stories with the star patterns that you see. So, Keith, thank you so much for joining us tonight on two segments, some top tips. I'm going to go and apply some of those right now. Um, we hope to see you in the upcoming lunar eclipse, which I'm going to tell viewers about in a second. But thank you very much for telling us
Thank
all
you for
about
having me.
meteor showers tonight.
Yeah, I always enjoy being on the show. So we'll see you then, and go outside and follow the tips and enjoy the show tonight. Hopefully, it'll be good for you.
Excellent. Thank you, Keith. Now, tonight may be about the Perseid meteor shower, but it's also a celebration of curiosity and exploration, I guess. Now, don't forget the Slew hosts regular star parties for eclipses, planetary conjunctions, and loads of other celestial events. So be sure to follow us for updates on upcoming broadcasts. And we have one particular spectacular event lined up on Sunday, September 7th, where we'll have live telescope views of the stunning blood moon total lunar eclipse. That is definitely not one to miss. Did I just see another meteor? I did. They're coming thick and fast now. Can you see? So we're 1:30 where this feed is coming from local time. That's UTC time on the screen. So we're after midnight, and this is when Perseids start to build. But anyway, it is time to wind up our star party. We have gone over time, so thank you very much for sticking with us. Thank you for joining us. And huge special thanks to our guests and feed partners tonight, Dr. John Bovair, SLU's Director of Curriculum, SLU Educators, Keith Wozaleski and Milton Villarol, and of course our Star Party producer, Gretchen Bickett. And I just saw another one just at the end of the show. And these events really wouldn't be possible without our wonderful group of feed partners. So thank you all for making that possible. And don't forget, if you're lucky enough to have clear skies tonight, remember that every meteor that you see is a tiny piece of that cosmic journey we've been talking about, a fragment from the depths of the solar system lighting up our world. Now, whether you spot one or dozens, I think we've probably had a dozen good ones tonight. Let the Perseids remind you that the universe is kind of alive with motion, mystery, and beauty. Now, on behalf of SLU, thank you very much for joining our live star party. We're always honoured to share these celestial events with you. Clear skies and happy meteor watching. Take care, everybody. Bye now.